Good afternoon. Tomorrow I'm supposed to teach standard form. I'm gonna upload the videos today. It just wasn't uploading for me today. It took like 2 hours to get just one video up. So that way you don't have to wait too long. I will teach standard form. This will be the standard form video. It's just a one video because there isn't in pieces. You'll see in a second. But you're wonderful. After today, then you should be able to graph vertex form and standard form. So tomorrow then, or maybe the next day, we'll see, I'll then upload a video that will just be an assignment of a mixture of vertex and standard form parabolas for you to graph. So you can then practice the two. Okay, here we go. Let's go. All right, here we go. Graphing quadratic standard form. It's an expanded form, which means there's all the foiling, all the combining like terms, all of that has been taken care of. So standard form is y is equal to ax squared plus bx plus c. It's a trinomial, okay? Yes. Okay, so now moving forward, once I teach this assignment and then once you complete the assignment, the other videos is not necessarily going to be me teaching you anything. Well, that sounds terrible. It will be all the different ways you could possibly get quadratic. So maybe the c is 0 or there's no b value, or, we'll take all the now variants of it, okay? Okay, so now here we go. Unlike vertex form where the vertex just pops out at us, here you have to find the vertex. It's not here looking at you. Now, once you realize, and I should have highlighted that, once you understand the formula to find the vertex, then yes, you then kick in your mental math. That's it. Okay. And then you can do it very quickly in your head, just as always, because it's minus b over 2a, you have to be respectful and mindful of the negative, okay? So when you're dealing with standard form parabolas, you have to be careful. You have to be very, very respectful of the negatives, okay? The mess ups will completely throw off your graphs, okay? All right, how do you find the x value to the vertex? The x value is always this formula, minus b over 2a. How do you find the y value or the y component? Because remember, the vertex are any points, right? The vertex is just a point. A point always has an x component and a y component. Okay, now in vertex form, they're called HK because that's the form in which it is written, right? There's an A, HK. Here, there is no HK, it's ABC. So your vertex is just strictly XY, okay, which that's not a leap. Okay, so you're going to substitute the value that you get from here, this number. You substitute it, you solve it into this original standard form equation, and voila, that's how you get your point. Okay, so it's just substitution. Not a big deal. And we will also, if I can find it, the calculator is actually really nice. Oh, I realized I didn't have the light on. Okay, the calculator is really great too for you to check your arithmetic, because even though order of operations, mistakes are made, human error is really high. Okay, so here we go. Let's find the vertex. We have y is equal to 2x squared plus 8x plus 5. So how do I find my vertex? A, B, C, right? All right, our formula is x is equal to minus b over 2a. So I put my little parentheses, and I'm going to fill it in. All right, minus, and then the b value is positive 8. 2a, the a value is 2. And so you just clean it up. And so I get negative 8 over 4, which is negative 2, right? Okay, so far my vertex is negative 2. That's half of it, right? So far I have negative 2. I need to find the y value. Okay, so how do we find the y value? Substitute the x value from above, plug it in, clean it up. So I have negative 2. This is my standard form. So I will substitute. Y is equal to 2. Is it negative 2? Okay. Negative 2 squared plus 8, negative 2 plus 5. And then you're going to just clean it up. Now, I will solve it by hand. However, if you have your calculator, remember, even for the vertex, hit the fraction button, negative 8, 2, oh, I didn't type it, and you get, oh, don't do that, equal. I hit the wrong one. You get -2, and here is my output as well. So the calculator will do it all for you. Okay, so let's type in this 2, right? So I'm going to type this in, and let's see if I can get that by hand as well. Right, 2, -2 squared plus 8, -2 plus 5, right? So this matches as well. Hit equal, -3. Okay, so I should get a -3 here, but let's solve it by hand. Order of operations, right? I'll take that first. So I get y is equal to 2. This is 4. What is 8 times -2? -16 plus 5, right? All right, oh, sorry. 2 times 4 is then 8 minus 16 plus 5, right? Right, because 2 times 4 is 8, -16. That came from 8 times -2, and the 5 is just carrying down. Okay, so now I have these 3 integers that I can just go ahead and add up. You could do it in your head, or now, if you want, you can go ahead and take it to your calculator. But 8 minus 16 is -8. -8 plus 5 is -3. And so you see, I got the exact same output value. Now, I know this isn't the cleanest. I just didn't want to... I didn't want to solve it on a separate sheet of paper because I wanted it to stay with this. Okay. Okay, so that is our vertex. So if you want to come down here, my vertex is -2, -3, which means my third slot is -2, -3, right? Okay. Okay, so now let's go ahead and look at our prompt. So because this is standard form, you can see that I still have an A value, right? That is still your A. We're still going to do a positive and negative. We're still going to answer concave up or down. Still max min point, still axis of symmetry, still max min value, vertex, XY table, and graphing it. That doesn't change. There is no HK. So that's really what changes, okay? Okay, so what is my A value? It's 2. It's +2, so this is a positive, right, number, so it's a positive. Parabola, which means it is concave up, which means it's going up, right? So that means my vertex is at the very bottom, right? So if it is at the bottom, then that means I have a minimum point and a minimum value, correct? Okay, so if I have my vertex, remember my max min point is always the same point as the vertex. So this is -2, -3. My axis of symmetry is a vertical line that crosses the vertex. So that means because it's vertical, it's the X value here. The minimum value is the Y value to the vertex, right? So this is -3, right? Okay. I just realized I didn't put vertical shift, horizontal shift. Well, that's terrible. I'll put it on the other assignment that I load, not the next one, but the other one. But we would look at the graph after. So actually, I can see why I didn't do that. Okay, so here we go. Equidistant, -1, -3. Those will have the same output values. 0, -4, right? Those will have the same output values. Okay, so again, you can go straight to this. Like if you have this in your calculator, right? And you want to be super, no, don't do that. Okay, here. And you want to be ridiculously efficient, just impressively efficient, or lazy, right? Substitute the 0, and notice I have 2 0 squared plus 8 0 plus 5. 2 0 squared plus 8 0 plus 5. Hit equal, and I get 5. So the calculator is definitely a time saver. I'll still solve it by hand. But then you have -1. You're like, no, that's okay, Miss Kenny. Just this video is long enough. Okay. But still, you should know how to solve it by hand. Okay, -1, hit equal, I get -1. So fast. Okay, if you wanted to solve it by hand though, so let's see if I can squeeze it here really quick. Okay, y is equal to 2, 0 squared plus 8, 0 plus 5. Okay, well that's easy. Anything times 0 is 0, so that's 0. This is 0, which makes this then 0. So voila, there's my 5. So good, 5, 5. That was a piece of cake. Okay, so now let's do the other one. 2, -1, plus 8, -1, plus 5. Okay, this is +1. 2 times 1 is 2, minus 8, plus 5. I'm writing through the camera so it could stay close, but I'm not writing as neatly. 2 minus 8 is -6, plus 5, -1, -1, -1. So there we go. Okay, so I was able to duplicate what the calculator gave me. Okay, so now you're going to go ahead and plot. My vertex is -2, 3. -2, -3 is here. That's my vertex. -1, -1. -3, -1. -4. Oh, I thought it was 5. I thought it was -5. I was like, oh my God, I messed up. 1, 2, 3, 4, 5. 0, 5. Yeah, that's right. Okay, and then this guy, 5. Okay, and so, whoopsie, it's moving. Okay, and so now my parabola, oh, that looks like a V. That looks terrible. Yeah. Oh, whatever. Okay, and so here's my beautiful, beautiful standard quadratic. Here's my axis of symmetry, right? So pretty. So it's not too bad at all. So the vertex form is the hardy information because we have to go through all of this, right? Okay, so if we wanted to talk about a horizontal or vertical shift, I realize we're not dealing with the H and K here, but look, typically the parent graph, they call it the parent graph, it's located, the vertex is located at the origin. Here, you all went through translations, and so this is just a translated parabola from the parent graph, which is a 0, 0. Okay, is your your horizontal shift was 2 left, 3 down, right? That was really your shift. So if we asked you what the shift was, whether I'll put H for horizontal, oh, I don't want to confuse you guys for the other. So no, I'll put horizontal. I don't want to mess you guys up. Horizontal and vertical, right? My horizontal shift was left 3, and my vertical shift was down, oh, no, this is 2. My horizontal shift is left 2, my vertical shift is down 3. And that just means from the origin, what happened to it? Where did this shift, where did it translate? Okay, when you study transformations, I think in IM1 possibly? Or I don't know if I taught you, I don't know. Like August seems so long ago. Okay, here's a second one. Should I do another video? It's 13 minutes. Let me shut it down and then let me put up the other video. Okay, bye.